In this video, cloud enthusiasts will learn about AWS Lambda and how it can help them save cost and focus on creating exceptional applications instead of stressing about infrastructure management. As a software engineer, when you develop applications, you need to know details about the compute platform your applications will run on, and if it is configured correctly. Once this part is taken care of, you also need to worry about making the platform scalable and available, which may require over-provisioning your infrastructure by setting up additional servers. From a software developer's perspective, this is a lot of additional overhead. It would be best for you to focus on writing business logic and not worry about compute platform related matters. But luckily, your organization is using a cloud platform, and you recently came to know about a service named Lambda and would like to know how it can help solve your problem. So let us dive right into it and explore its capabilities. Lambda is one of the many available compute platforms on AWS. However, the difference between Lambda and other compute platforms such as EC2 is that Lambda is serverless. And because of its serverless nature, it lets you run code without provisioning or managing any servers. Cloud Platform Provider handles all the heavy lifting of the administration of computing resources, including servers, operating system maintenance, capacity provisioning, and scaling needs. In contrast, the developers can focus on building the business logic of their applications and then supply the code to the Lambda engine to run. However, because the cloud provider manages the platform, you do not have an option to customize operating systems by logging into the compute instances. Lambda is not the right choice if you need to configure resources such as operating systems based on specific needs. When using Lambdas, you as the developer do not have to concern yourself with your application's ability to handle varying traffic loads. Since Lambda manages the infrastructure that runs your code, it can scale automatically in response to incoming requests, and Lambda can scale up by running additional instances when your function is invoked more quickly than a single instance of your function can process requests. When traffic subsides, inactive instances are frozen or stopped. When you invoke a function, you can invoke it either synchronously or asynchronously, depending on the use case. In the case of request-response-based scenarios, synchronous invocation is often used, in which the client waits for the function to process the request and return a response. API Gateway is a good example. An incoming API call is forwarded to the Lambda for processing, and the response is sent back to the client. In contrast, Lambda queues the event for processing in an event-based system and returns a response immediately in the asynchronous invocation model. S3 events are an excellent example of asynchronous requests. A new object uploaded to an S3 bucket could trigger an event that could invoke the Lambda for additional processing. You can author your Lambda functions in various languages supported by the Lambda platform, such as Java, Node.js, Ruby, Python, Go, C#, TypeScript, etc. Lambda is cost-effective for organizations. You pay only for the compute time that you consume. So if your code is not executed, there is no charge. All these benefits make it very compelling for organizations to think serverless first. In summary, Lambda could be a game changer for organizations, especially for startups. Please do not forget to support our efforts by subscribing to our channel. Thanks for watching.